All right, so today we're going to dive into something really cool, a blueprint that tries to bring some serious structure to the, let's be honest, kind of chaotic world of AI development. It's called the G2 Test-Driven Development Framework. And yeah, it might just be the thing that changes how we build smart systems from the ground up.
I mean, that's the million-dollar question, isn't it? If a system can learn and adapt on its own, how in the world can you guarantee it's reliable? How can you be sure it's secure? That unpredictability is exactly the problem this whole framework is designed to solve.
So that brings us to our first big hurdle, this idea of testing the untestable. With AI, all the old rule books for making sure software is solid, you can pretty much toss them right out the window.
Think about it like this. Normally when you write code, if you put A in, you expect B to come out every single time. It's predictable. But with AI, you put A in and you might get B, you might get something kind of like B, or you could get Z. And while that power is amazing, it is an absolute nightmare for quality control. We clearly need a whole new playbook.
And that, right there, is where the G2 TDD framework comes into the picture. It's a totally different way of thinking, a new blueprint for building AI that has quality and trust baked in from the very first step.
And here it is. I know, it's a hand-drawn diagram, but this is our roadmap for the whole process. It lays out everything, from the developer's first idea all the way to a finished piece of software. So let's really get into it.
Okay, let's pop the hood on this thing and take a look at the anatomy of the framework. We're going to see how all these different parts work together to create a really disciplined, repeatable cycle for development. So from a bird's eye view, the process is actually pretty straightforward. First, a human developer sits down and writes a bunch of tests that basically say, here is exactly what this piece of software needs to do. Then you let the AI loose. Its only job is to write code that can pass all of those tests. The result of that is something called the software artifact, a totally self-contained, testable piece of the puzzle. And finally, you take these proven artifacts and snap them together to build your final product.
Now, for any of this to make sense, you got to get this one core idea: test-driven development, or TDD. It basically flips the normal way of doing things completely on its head. Instead of writing your code and then figuring out how to test it, you write the tests first. Those tests become the ultimate blueprint, the non-negotiable specs for what the code absolutely has to do.
And what's so fascinating is how this changes the developer's job. If you look at the diagram, the developer isn't just a coder anymore. No, they're the architect. They're the referee. Their whole job is to design the boundaries and define the rules of the game before the AI even gets to play.
And this is where the magic happens. The AI takes all that input, the tests, the specs, the data, and it just goes to town, generating code to meet every single one of those requirements. It's kind of like giving it a really complex puzzle box and saying, figure out a way to solve this, but you have to stay inside these lines.
So what comes out the other side isn't just some messy blob of code. It's what the framework calls a software artifact. And this right here is the real game changer. It's a self-contained, independently verifiable module. That means, in this crazy world of AI, you get a piece of software that you can put through its own security audit, its own testing, and you know it's solid before it ever touches the rest of your system.
Okay, that all sounds great on a whiteboard, right? But how does this actually work in the real world? Let's take a look at the framework in action.
And these aren't just theories. The framework's been used in a bunch of live coding sessions. We're talking projects like building out an MCP game server, creating a secure endpoint for the KeePass password manager, and even generating brand new software modules completely from scratch.
Let's just zoom in on that KeePass example for a second. So, CRUD just means create, read, update, and delete. The basic things you do with data. To build this using the framework, a developer would start by writing a whole suite of tests that define exactly how this thing has to handle sensitive password data securely.
The AI then gets to work churning out code until it passes every single one of those security and functionality tests. So what you get is a software artifact that is provably secure before it's even part of the main application. You're not just hoping it works, you have the receipts to prove it.
Now, let's zoom back out to the big picture here. That KeePass artifact, it's now just one trusted component in a much larger software product. By just repeating this cycle over and over, you can assemble a really complex, robust, and trustworthy application from a whole collection of these individually verified parts. It's like building with certified Lego bricks instead of a bunch of mystery clay.
So why does any of this really matter? I mean, why not just let the AI go wild and code whatever it wants?
Well, the answer really comes down to the huge benefits you get from this kind of disciplined approach.
Let's break it down. You get auditability, you can prove each piece is secure on its own. You get reliability because you're building with pre-vetted parts, not just crossing your fingers and hoping for the best. You get clarity because the developer is forced to think through every single requirement right from the start. And finally, you get modularity, reusable, dependable building blocks. Look, this isn't just about building AI anymore, it's about building AI we can actually trust.
And that really leaves us with one final thought to chew on. As these AI systems get more and more powerful and woven deeper into our lives, our need to trust them is just going to skyrocket. So the real question is, could disciplined, human-guided blueprints, just like this framework, could they be the key to finally unlocking a future where AI is truly and fundamentally trustworthy?